Welcome to the YouTube channel MSP432 project. This is my project for microcontroller technique at the FH Aachen using an MSP432. So, what was my task? I had to remote control an RGB LED. In order to remote control something, you need a remote control. So let's start talking about this. The remote control is this unit over here. It has a joystick, 2 buttons, and also like this LED currently being green, but I'm going to reset it to get, and then it initially lights white. Those elements I'm going to use in order to remote control this LED on the receiver board. So how are we controlling this RGB LED on the receiver board? We're navigating within the HSV color space. To those of you who aren't familiar with the HSV color space, I'm giving a brief explanation to you. That's the HSV color space. It's basically a cylinder with the value, saturation, and hue, hence HSV. So the hue gives you the angle you're looking at this cylinder. The saturation gives you the depth. So when the saturation is high, you're on the outer diameter of the cylinder. As it decreases, you're going inwards into the cylinder. On the outside, there's a more vibrant color. On the inside, there's let's call them more foggy colors. The value gives you the brightness. So on the bottom, there's black. On the top, there are like the really bright colors and also more of the white space. So in order, for example, to get from red to green, we would have to rotate the cylinder from 0 degrees to 120 degrees. So let's do it. I just have resetted this microcontroller, so we are at the initial 0 degrees. So in order to actually see at which color we are, we would need to decrease the saturation, increase the saturation to get onto the outer diameter. This can be done with this button. This down here increases the saturation and this decreases it. Then to rotate the cylinder, in order to get towards green, we need to rotate it counterclockwise. This can be done pushing this joystick to the left, to the right. There we are in the yellowish color space, and there we are in the greenish color area. So now we would like to enlight this RGB LED on the receiver unit. So this one here in green. Therefore, we to transmit the color, we're using an infrared LED, and the transmission process is started when pressing the button on the joystick down. What we can see is that the LED on the receiver module now shines. It's flickering on the screen pretty heavily, but in real life, when standing in front of it, you wouldn't see that flickering. It's because my phone records in roughly the same frequency as the pulse width modulation of this RGB LED is done. That's what's causing interference, and hence you see the flickering. But what we can notice is that it's supposed to be green. It isn't. And yes, that's a bug. But before getting into the bug though, let's first talk about what we can see on the receiver board. First, we see this infrared receiver here. An infrared receiver you can think of as a big resistor, which decreases its resistance when it's exposed to infrared light. Then, of course, we got the RGB LED and the ATtiny 13A. Yeah. So now let's talk about that bug. Initially, I thought that when choosing the ATtiny 13A, that it has 2, maybe 3 timers. I didn't dug too deep into the datasheet. I looked at the pin configurations and the naming on there, and yeah, there was names where I thought, well, that's probably a timer. And yes, it has a timer, 1. I would need at least 2, best would be 4, but 2 would be enough for my use case here. So this 1 timer it actually has is used in order to control this RGB LED. Since 1 timer with 2 outputs, which are very limited in configuration, they aren't as independent as those on this MSP432. So I had to stick to interrupts. So I timed an interrupt, which is like counting up to 255, and then also the maximum value of the RGB color space, which then, yeah, this counter checks whether the RGB value of this LED, the HSV color space we're controlling, is converted into RGB later on before transmitting. There we check if this RGB value is smaller than the counter. If it is smaller than the counter, then the LED is off. And yeah, if it's bigger, it's on. So at 255, the single color wouldn't be off at all. So that's how we get the color. But let's get in. So in order to transmit the bits, I'm using, or I was planning to use, the standard IEEE Manchester code. Yeah, I couldn't use the standard Manchester code since I don't have a timer. So what I did is I estimated the signal with using a counter, which counts if this pin is pulled down on the ATtiny, and this initial signal gives me the length of each single bit transmission. There comes my second issue. The estimation doesn't really work at all, it does not work at all. It goes on, but it doesn't give me the correct value. since I think it's optimized away, I couldn't disable optimization since otherwise I wouldn't be able to fit my code onto the 80 tiny sort array. So I had to enable optimization, and since for loops are only wasting times and compiler nowadays are pretty good in noticing something which yeah, seemingly does nothing. Um, so yeah, I don't even have those estimations, presumably. Um, so yeah, then thank you for your attention. And also the typical YouTube boilerplate things. I always wanted to do that. Please to subscribe to our professor channel and check out all the other videos on this channel. There are some really amazing projects. You don't want to miss them. Bye.